Coming to discharging of capacitor. Now suppose you take a circuit where you are having a resistor and another one is a capacitor. Okay, resistor is there to protect the circuit from high charging current. Okay, so because otherwise if we will not use the resistor, the current will be very high, it may damage the circuit. So here we are using a capacitor and a resistor. Now this is discharging of capacitor. Discharging means the capacitor is already charged. The capacitor is already charged. Now you are going to discharge the capacitor. Okay. So now what will be the, all of you listen carefully, what will be the voltage across the capacitor there? What will be the voltage across the capacitor? So voltage across the capacitor, net it is Vc is equal to capital V. A long time the switch has been closed, the capacitor has been charged to the supply voltage V. Okay, so here Vc is equal to the voltage across the capacitor is equal to how much? The voltage across the capacitor is equal to how much, tell me?
V.
Yes, the voltage across the capacitor is equal to your V, capital V. Okay. Now, what is the charge in the capacitor? Capital Q. Because the voltage is maximum, the charge will also be maximum at that point. Yes or no? Just recall what you have read it in here during the charging of the capacitor. So the voltage across the capacitor is maximum. That is, it has charged to, it has acquired the voltage to, or it is having a potential difference of capital V. The charge is equal to capital Q. Okay. So now here you take Vc as the voltage or potential difference across the capacitor. Voltage across the capacitor. I is the, here instead of charging I will write down discharging current. This I have taken as charging current during the charging of capacitor. Now here I will write down discharging current. I is the discharging current, Q is the charge on capacitor. Q is the charge on capacitor. Okay. So now the capacitor is fully charged. Okay. Now the switch is open. You have charged the capacitor to capital V. At that the charge is maximum. Now take it as an instant you are closing the switch at t is equal to 0. Listen all of you carefully. Okay, you take it as an instant where the capacitor is charged to capital V and you are closing the switch. Tell me, Then at the instant I am closing the switch, just wait. Okay. So tell me. So at t equal to 0, you are closing the switch. Okay. At the instant of closing of the switch. Of closing of switch. Tell me. What will be the current in the circuit? What will be the voltage across the resistor? Let it be VR. What is the voltage across the capacitor? Tell me.
मैम एट एन स्टार्ट मैम सर्किट मैम एज अ क्लोज्ड सर्किट की तरह बिहेव करेगा.
Okay, so what will be the current in that circuit?
वी आर आई
What
आर
will be the current? VR will be equal to how much? And what about VC? Tell me.
वीसी मैम वी
Just at the instant of closing the switch, what will be the current in the circuit? Think and tell. See the circuit properly and tell.
Ma'am, repeat once.
It will be equal to how much? Yes, yes, tell. Tell.
My bar. No,
Yes.
we bar.
Some more answer. I want. Tell.
VR by R.
Look at the circuit properly and tell.
वी आई आर प्लस वी
V R plus how much?
वी
V R plus V. This much. No.
यस
No. See, this will act as a, listen, this capacitor will act as a what? Voltage source. It
यस
is
मैम
having a potential difference of what? It is
V.
having a potential difference of V. So at that time, what will be the current in the circuit? Current is equal to how much? V divided by R. Okay?
Yes,
Got it
ma'am.
or not? This is your maximum current. This is your maximum current. Am I clear to all of you? Got
Yes,
it?
ma'am.
So this is your maximum current. Now what will happen? This current will go on because you have given a potential difference of or the charge is having capital Q. Now you have closed the circuit. The discharging current will flow in this direction because once it is charged, okay, with this one as a positive, look at here, this one will be your positive, this one will be a negative. So current will flow from higher potential and it will enter into the lower negative potential, higher to lower. So here positive will be acquired here in the left side plate, negative will be acquired at the right hand side. Okay. So now while discharging, what will happen? This has acquired a voltage of V volt. So now when we are going to discharge, I am closing the switch. Now in which direction the current will flow? The current will flow in the opposite direction. Am I clear to all of you? The current will flow in the opposite direction. So here you see the charging current and the discharging current are opposite. Am I clear now? The charging current was in the clockwise direction, but discharging current is in the anti-clockwise direction. Am I clear now, or is there any doubt?
मैम एक बार फिर से समझा देंगे.
Yes, ma'am.
Okay. Okay. So here you see, once this is initially what is happening. Just see. Initially, what we are doing? We are charging the capacitor with this one as positive. This is negative. Okay. Here we are having a resistor. Here I am having a capacitor. So while charging, the current will start from higher potential. This is positive and this is negative. The current will charge from the current will flow from the higher potential. Now, in which plate it will acquire positive and which plate it will acquire negative of the capacitor? Positive will be acquired here. Yes or no? Negative will be
Yes, ma'am.
here. Okay. So same thing I was telling. So now that means charging current was in the which direction? Charging current was in the which direction? In the
Clockwise.
Opposite direction.
clockwise direction. Clockwise direction. Now while discharging, what will happen? I am disconnecting the voltage source what I am doing it is, I am just connecting a switch here. I will close the switch. So this will act as a voltage source, right? This will act as a voltage source because no other source are there. So now the current will start from where? It will start from this positive end. Got it or not?
Yes, ma'am.
Got it or not? All of you understood? Those who are asking the question?
Yes.
Yes, ma'am.
Got
Yes,
it all
ma'am.
of you? Okay.
Yes, ma'am.
So now the current will flow. In which direction the current will flow? The current will flow in the
Opposite direction.
anti-clockwise direction. Okay. So charging current and discharging current are opposite to each other. Got it all of you?
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Okay. So now here, yes. So now here, initially, what will happen? Initially, you are having only a resistor and this is a voltage source. Okay, this is going to discharge. This positive, this is acting as a voltage source. So now what will be the current in the circuit? What will be the current in the circuit if it is having a V, this is R. So what will be the current in the circuit? Tell me. It is V by R?
We were.
Yes, ma'am.
So that is
Yes,
your
ma'am.
maximum current will flow at the instant of switching. That means as t equal to 0, what will be the value of the VC? VC is equal to capital V. Current is equal to maximum, that is equal to V by R. Am I clear to all of you now?
Yes, ma'am.
Clear to all of
Yes,
you?
ma'am.
Yes, ma'am.
Okay. Okay. Now come to the charge in the capacitor. So what will be the charge in the capacitor? Q is equal to capital Q. Okay. So now it will go on. Suppose a long time you have closed the switch. Okay, coming to the third case. This is the first case at the instant of switching. Third case is a long time the switch has been connected to the circuit. A long time switch is connected to the circuit. Okay, this is the third case. In between what is happening, I will discuss. So a long time switch is connected to the circuit. So consider the case this long time the switch has been connected to the circuit, that is t at infinite. Okay, what will be the condition of the circuit? You think of a very long time.
मैम कैपेसिटर डिस्चार्ज हो जाएगा मैम और वो ओपन सर्किट की तरह बिहेव करेगा करंट
वेरी गुड. आप कैपेसिटर डिस्चार्ज करके ओपन सर्किट हो जाएगा. ठीक है. एनीबडी इन ऑल ऑफ यू एग्री विथ हिम? Capacitor will get discharge thing. Capacitor will get discharge means there will be no charge. Q will be equal to 0, right? What about the VC? VC will also be equal to 0, right? Okay. What will be the current in the circuit? इसका charge ही नहीं है. No potential difference. So what will be the current in the circuit? Tell me quick. What will be the current in the circuit? Current in the circuit. Tell me. 0 will be the current. Yes. 0. No potential difference. How the current will be there? VC is equal to 0. So now tell me what in the first case and the third case. Here, what is my current? 0. Q equal to 0. VC is equal to 0. Here, current is equal to V by R. VC is equal to V. Q is equal to capital Q. Now, what is the difference in the capacitor condition at the t equal to 0? What is the capacitor condition at t at infinite? Tell me. T at 0, VC is equal to V. That means what? It is having a potential difference of capital V. Yes or no? Yes or no? So current at that time T at 0 equal to, it is maximum current. Okay, clear? So a long time the switch has been closed to the circuit, current is equal to 0. No current is flowing. Okay, capacitor voltage is 0 means it is behaving as what? It is behaving as open circuit or short circuit? Behaving as open circuit कैसे हो गया? वो potential difference 0 है.
शॉर्ट सर्किट
Potential difference is 0. No potential difference. Okay, this and is same. Same. Understood? Got it or not?
Yes, ma'am.
There is no potential difference. If I am having putting a resistor here, okay, or if there is a voltage source here, I will remove and I will sort it. I will just sort this two terminal. What is the potential difference? Potential difference is 0, right?
Yes, ma'am.
So it will behave as a short circuit. Okay. So here, all of you got it or not? Understood, all of you? 12 sides
Yes,
understood?
ma'am.
So first condition, this is the third condition. Now coming to the second. Second is at any instant of closing of the switch. At any instant of closing of the switch. Okay. So this is the condition between t greater than 0, t greater than 0, less than infinite. Okay. So what happens? This condition is called as the transient condition between t at infinite to t at 0 to t at infinite. So you tell me what will be the equation of the circuit? What is the equation of the circuit at t between 0 to infinite? It is just after closing of the, it is after closing of the switch, before long time the switch has been closed. Okay, that we call it as the transient condition. So now here you tell me what will be the equation in the circuit. This is a capacitor. Normally it is behaving as a voltage source. The switch has been connected to the circuit. Okay, here the switch has been connected to the circuit. Okay, so what will be the equation in the circuit? Tell me. This is R, this is C, this is VR, this one is VC. So what will be the equation in the circuit? No voltage source is there. Okay, so 0 is equal to how much? VR plus VC. I can write down. All of you agree with me?
Yes, ma'am.
Yes, ma'am.
Okay, so this is 0 is equal to VR plus VC. So V equal to, this implies VR is equal to how much? I have told you last class, you see VR is equal to, this implies 0 is equal to or VR equal to IR plus VC. This is equal to how much? Last class I have told you, see the equation, see your copy and tell me what is the value I have taken. I is equal to dq by dt I have taken. See that equation and tell me. Q is equal to C into VC. Q is equal to C into VC. So this is how much? C dVC divided by dt. Have I found it out or not?
Yes, ma'am. You've done this.
Okay. So this is just to substitute this one. This will be how much? RC dVC divided by dt plus VC equal to 0. Got it, all of you? Got it or
Yes,
not?
ma'am.
So this implies differentiation of VC divided by VC. This will be equal to minus dt divided by RC. Got it, all of you? Understood? Derivation
Yes,
is
ma'am.
important. You will get derivation. Okay. So now integrating both the sides, my aim is to find out the value of VC. So integrating both sides, integration of dVC by VC is equal to integration of minus dt divided by RC. Do the integration, tell me. Do the integration and tell me. This will be ln VC equal to how much? Minus P divided by RC plus K. This is your integration. Okay, this is your equation. So K is your integration constant. It can be found out from the initial value. So initial value is when T equal to 0. What is the value of the voltage across the capacitor? When T is equal to 0, VC was equal to capital V. Yes or no? So what will be the value of the integration constant? Integration constant A will be equal to how much? ln V. Got it, all of you, or doubt? Anybody having any doubt, tell me at that instant. Okay. Now what you will do it is, you substitute the value of the integration constant in this equation. So what you are getting? After substituting the value of the integration constant in that equation, you are getting ln Vc will be equal to minus T by divided by Rc plus ln V.
B.
So this implies how much? Ln Vc divided by capital B is equal to minus T divided by Rc, or this implies Vc divided by V is equal to e to the power minus T by Rc, or this implies Vc is equal to how much? Capital V to the power minus T divided by Rc. This is the equation of the voltage across the capacitor. That means this is at any instant other than t and infinite. This is the transient condition. Okay, so you substitute t in this equation. What are you getting? Tell me. Are you getting first condition I have tell you? You just check it whether you are getting the same value or not. T equal to 0. What is the value of Vc? Here you are getting in the equation.
B.
V.
V, ma'am.
T at infinite.
V.
T at infinite. T at infinite. What is the value of V? What
Zero.
is the value of Vc?
Zero.
Have you got it or not? Those values?
Yes, ma'am.
हम थोड़ा ऊपर की
Yes or
जगह
no? Okay, all of you have got it or not? Tell me.
Yes, ma'am.
Yes, ma'am.
Okay, very good. यहाँ पर और ऊपर.
Yes, ma'am.
Okay. So this is your voltage across the capacitor at any instant. Now here I will tell you one thing. 0 to infinite, don't think that it is a very long time. This is a very fraction of a second. Very, very less time. It's for a capacitor to charge to the whatever the voltage it has been given. Suppose you take a capacitor, practically you have solved many circuits. You have solved mesh analysis, nodal analysis, Thevenin's theorem, Norton's theorem, start and in none of the cases you have used capacitors and inductors. Have you used? Tell me. Have you used?
No, ma'am.
No. Why you have not used? Capacitor, suppose I am using a capacitor, I am giving a DC voltage to a capacitor. You can check it. If you give DC voltage to a capacitor, okay, whatever is the voltage, you will see that immediately it has charged. Suddenly it has charged and it has become open. It is behaving as open circuit? Yes or no? It is behaving as open circuit or not? You see here. I have to. Sorry. Okay. It is it will behave as short circuit? Yes or no? Not open circuit. It will behave as. During the charging, it will behave as open circuit. During discharging, you immediately open the switch. What will happen? It will come immediately discharge. Am I clear to all of you? Am I clear? You take
Yes, ma'am.
मैम एक बार फिर से मैम.
I am telling you. You take a capacitor and you apply some voltage. Some voltage you will apply. Okay. Suppose you will take a 5 volt capacitor, 5 volt battery. You will charge the capacitor. You will see that very small time it is required for the capacitor to charge. It will immediately charge to 5 volt and no current will flow. That means it will behave as an open circuit and the initial condition. Yes or no? What it?
Yes, ma'am.
Okay, it will suddenly charge to the supply voltage and no current will flow. You have considered during the charging of the capacitor. Similarly, during the discharging, you remove this one, remove the voltage source here. It will immediately discharge and this will become 0. Again, I am telling you this. You take a capacitor and you give some voltage here. DC voltage you give. All of you listen, this is a very important thing. Give some DC voltage here. Suppose you take it, give it 5 volt. You will see that immediately the capacitor will charge. Okay, we are telling that T is greater than 0, it is less than, T is greater than 0, it is less than infinite. This 0 to infinite time period is very, 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 very less. That is the reason why it is called as the which period? Transient period. Understood all of you? All of you got it or not? Got it or not, all of you?
Yes, ma'am.
Okay, so this
Yes,
is a
ma'am.
very less. We are telling that 0 to infinite, but that infinite period is very less. It is very less. That is why it is called as the transient period. So certainly it will charge. You have seen during the charging condition, you have seen that it is charging from 0 to what? Infinite. 0 to capital V. It is going at P at infinite. But this period is itself very less period. Very less time. Am I clear now what I want to tell you? Understood?
Yes, ma'am.
So same students are answering. Why other students? Okay. So now here you have seen that yes, during the discharging condition it behaves as a short circuit. Charging condition it behaves as an open circuit. So here, what about the voltage? Similarly, what about the charge? Charge Q will be equal to how much? Q will be equal to capital Q e to the power minus T by RC. Same, the voltage and the charge will discharge or will fall like this one. Yes or no? Because Q is equal to C into Vc. Understood or not?
Yes,
Yes,
ma'am.
ma'am.
Okay, so now coming to the current. Similarly, what will be the equation of the current? Tell me. Anybody find out equation of the current? Find out what is the equation of the current. Tell me, what will be the equation of the current? Tell me.
And V by R e power minus T upon RC.
V by R, how much? E to the power minus T by
minus T by
RC.
RC.
T by R.
So here we'll put a minus sign because the discharging current direction is opposite to that of charging current. Discharging current direction is opposite to charging current. That is why a minus sign is given. Understood? Clear to all of you?
Yes, ma'am.
Yes,
So
yes,
now okay, very good. So now I will draw a graph between voltage across the capacitor versus time. Okay, what will be your equation? Initially T at 0, what is the voltage? Voltage is equal to capital V. T at infinite, what is the value of the voltage? Voltage is equal to 0. So that means it is 0 at T at infinite. What is the equation here? Tell me. What is the equation? It is equal to V to the power minus, it is equal to V to the power how much? Minus
T upon
RC. So this is your transient condition from 0 to infinite. Actually, this graph you are showing, but if you see in the MATLAB, in the software, one experiment is there. If it is possible, I will show you in the laboratory. You will see how much time a capacitor is taking from fully charged to become discharged. You will see that very less period of time. That period is known as the transient period. This period is known as the transient period. That is a sudden change. It is charging immediately. If you switch off, it will discharge. Okay, and you give the voltage, immediately it will charge to capital V, whatever is the voltage you are providing. Similarly, if it is a charged capacitor, you suddenly remove that voltage, supply voltage, it will suddenly discharge. Okay, this happens in a very quick period of time. The charging and the discharging of the capacitor, it happens in a very short period of time. That is known as the transient period. So for that purpose, in the DC circuits, we are not using the capacitors and inductors. Am I clear now?
Yes, ma'am.
Yes, ma'am.
Okay, fundamentally you are clear. Okay, very good, very good. So now coming to the charge, this is Q is equal to, you are taking Q here, sorry, time period here, and this is your Q. Okay, time period, this one is your Q. So initially charge is the maximum, finally the charge is equal to how much? 0. Now it will fall like this. So this is equal to, Q is equal to how much? Capital Q to the power minus T by RC. Am I clear to all of you?
Yes.
So now last one is what? Current. Current versus time. So this is my plus, minus will be in the downward direction because charge discharging current is minus. So from I maximum at t equal to 0 to 0 at t at infinite. So here t at infinite, it will be 0. And in between, what is the equation? The equation is Im e to the power minus T by RC. Now, no need to put a minus sign here because already I have shown it in the negative axis. Am I clear now?
Yes, ma'am.
Yes, ma'am.
Okay, very good. Fundamental clear, or anybody having any doubt, tell me. Anybody having any doubt, tell me.
No, ma'am.
Written all of you? Anybody have not written, tell me? All of you have written?
Yes, ma'am.
Yes, ma'am.
Okay, very good. So
Yes,
now
ma'am.
we
Written,
will.
ma'am.
Okay. So now we will go for. Yes. Go for time constant. How do you define time constant? Time constant, that is your time. So here you substitute the equation of Vc is equal to capital V to the power minus T by Rc. You put T equal to lambda, that is equal to Rc. You substitute here. What is the value of the voltage across the capacitor you are getting? Tell me.
V power minus 1.
D to the power minus 1. E to the power minus 1, last class how much you have taken? That I want.
0.67.
0.67. So this is equal to 0.67 capital V. So now how you define the time constant for the discharging? It is the time required for the, yes, define, it is the time required for the capacitor voltage, time required for the capacitor voltage. Yes, tell me. Capacitor voltage
Decrease the voltage by
to decrease to how much? 0.6 times
Six,
of its which value? Final value. Similarly,
Ma'am, I guess VC is equal to 0.37 V over.
सर देख करके भी नहीं बोल रहे हैं. Please answer. Please, sir, na? Thank you. Who answered? Tell me. Let me know your name. Who told?
Raviraj Shrivastava.
Very good. Very good.
Yes, ma'am. VC was 0.37.
You came to very quickly, na? Who is answering? Huh?
Ma'am, Satyabhi.
Satyabrata.
No, ma'am. इसके लेट है मैं देखें.
So now this is your time constant. So similarly you can write it for the current. Okay. Similarly you can write it for the current. Current will be equal to how much? What is the current? Current is equal to Im into how much? E to the power minus T by Rc. So you put T equal to lambda, that is equal to how much? Rc. Lambda is your time constant. Substitute here. How much you will get? It will be equal to 0.37 times of how much? Maximum current. So it is the time required. What will be the time constant? It is the time required for the discharging current or current of the capacitor to what? Decrease to how much? 0.37 times of its maximum value. .37 time of its maximum value. Understood all of you? Now here I will do a problem. Written all of you? Or anybody has not written here? Anybody have not written? Anybody have not written? Tell me.
मैम यहाँ पे भी करंट डिक्रीज हो रहा है कि इंक्रीज हो रहा है?
ऐसे मैक्सिमम से आ रहा है ना, मैक्सिमम होकर के जीरो में आ रहा है ना.
बट नेगेटिव साइन, अच्छा वो सिर्फ डायरेक्शन के लिए शो है नेगेटिव साइन.
अरे करंट का नेगेटिव मतलब क्या? डिक्रीज हो रहा है क्या? करंट का नेगेटिव मतलब उसका डायरेक्शन चेंज हो रहा है. Okay, so now we'll do one problem. Yes, I was supposed to start for inductor, but I will do a problem. Problem all of you do. I will ask you. A2 माइक्रोफैराड कैलकुलेटर जिसके पास नहीं है कल लेकर के आकर के बैठो. Within that period I am writing the question. A 2 microfarad capacitor is connected by closing. मेरा हैंडराइटिंग देखकर पता नहीं चलेगा. टेल मी, आई विल रीड इट. ओके. By closing a switch to a supply, all of you mute yourself, of 100 volt to a 1 mega ohm series resistance. You have to calculate. There are different beats. You will calculate. One is your time constant. Second one, initial charging current. Initial charging current. Third one, the initial rate of rise of potential difference across capacitor. Then number 4, voltage across capacitor. Voltage across capacitor. 6 seconds after the switch is closed. After the switch is closed, who was muted? Unmuted. time taken for the capacitor to be fully charged. करो, जल्दी करो, और एक दो प्रॉब्लम करोगे. One thing I want to ask you, whether you can tell or not, let me know. Let me see. Suppose you are taking a capacitor, how much time it will take to be fully charged? Tell me. You are taking a capacitor. Yes. Tell me how much time it is taking to be fully charged. I have given that problem in the last point. Time taken for the capacitor to become fully charged. Tell me how much it is. Any capacitor you take. I am not asking for this particular question. You know it or not? Tell me.
No.
मैम भूल
हाँ
नहीं मैम भूल गए.
हाँ ठीक है ठीक. Anybody know? It is, remember that it is equal to 5 into RC. 5 into time constant. It takes 5 into RC. A capacitor takes to become fully charged. You may get short questions or in quiz question. To become fully charged, it takes 5 into RC, almost 5 into almost full charge. If it is, if you give this much time, 5 into RC time, it will be almost fully charged. Understood all of you? Remember this value.
Okay, ma'am.
Okay. Yes. Now tell.
Yes, ma'am.
Now do this problem. Do it. What is the time constant? Tell. What is the time
2
constant?
seconds.
Time constant is 2 seconds. Very good. Just wait. All of you have written the question. I will
Yes,
move
ma'am.
it. Okay, very good. So now answer first bit is how much? Time constant is equal to RC. That is how much second? 2 seconds. Number 2, initial charging current means initially what is the charging? What is the current? You see it during the charging case. This is the charging condition. So you see whatever I have taught you in the during the charging of the capacitor. What is the current in the capacitor at the instant I am closing the switch for charging of the capacitor? What was the current? Tell me.
Zero मैम.
मैम V by R.
ये क्या? Zero.
या मैम V by R सर मैम V by R. V by R.
ठीक है ठीक है. So your current is maximum at the charging when you are providing a voltage source for charging of the capacitor. You suddenly close the switch, or at the instant of closing of the switch, the current is initially maximum. Okay, after that it will become zero, because when the capacitor will be charged to the supply voltage, then there will be no potential difference, so there will be no current. Okay, so the current will be maximum at that case, that is equal to V by R. How much you have calculated? Soham, have you calculated? Soham?
Yes, ma'am, calculating.
Calculated? Okay, very good. अच्छा, V by R is equal to how much? कितना आ रहा है?
मैम मेरा 10 power 8 आ रहा है.
10 power 8. Yes. I am getting 100 micron. Correct. Okay.
Yes, 100 micron.
100 micron.
Okay, very good. Then third, initial rate of rise of voltage across capacitor. Third bit is initial rate of rise of voltage across capacitor. What is the equations? All. In these types of question, in here, you will get derivation. Otherwise, if you are getting a problem, put the formula, find out the answer. These types of questions you will get. So formula you have to remember. So what is the value of rate of rise of voltage across the capacitor? Tell me, what is the formula?
Ma'am, dVc by dt.
Who is answering? Let me know.
Ma'am, Satya bro.
Arey, same Satya. Rest students are not there.
Ma'am, equal to V by RC.
V by how much?
RC.
V by RC.
RC. How much it is coming? It will become as 50 volt per second. Okay.
Yes, ma'am.
Number 4. Number 4.
मैम
हाँ बोलो
मैम ये थर्ड बिट थोड़ा समझा देंगे, मेरे को समझ में नहीं है.
प्रसाद
यस
सुप्रसाद
मैम, यस मैम.
तुम जो चार्जिंग ऑफ कैपेसिटर आई हैव taught you, you open that one, have you written?
यस मैम रिटन.
So you see that have I given this formula or not? See, have I given this formula? Tell. See, if you are not able to understood, then tell. Have you seen? Have I written this formula or not? Tell me.
यस मैम, यस मैम.
You understood how it is coming or not?
Yes ma'am, got it. I was searching for that formula. Got it.
Yes. Okay. You got it? How it has come?
Yes ma'am.
Okay. So here, this is your formula. So you will put the formula and find out the answer. Next is, what is the bit? Next, what is the question? Next, what is the question you tell?
Voltage across capacitor 6 seconds after the switch is closed.
6 seconds after the switch is closed, why it will be 0? Why it will be, what is the equation? What is the equation? Tell. BC equal to how much?
B into 1
minus e to the power minus t
minus
by
t upon RC.
यहाँ पर सब वैल्यूज डालो. T equal to 6 second.
6 seconds आता है.
95.021.
95 point, very good. Who has calculated? 95 point. Kaustav, Mitra.
Yes ma'am.
Yes, very good. 95.1 volt. This is the answer. Next, 5. Those who are doing, tell me the answer. Tell me your name. I should know who is doing. Number 5. Then time taken for the capacitor to be fully charged. Just now I have told you how much it is.
10 seconds.
5 times 10 seconds.
10 seconds.
Very good. Very good. Now another question I am giving you. 5-6 minutes is there. Another question I am giving. Acha, you know what is the charge stored in a capacitor? Energy stored in a capacitor.
Half CV square.
इतना धीरे क्यों बोल रहे हो? Half CV square. Okay, this is the energy stored in a capacitor. This formula you have read it in your 12th standard. No, this is not required. So now coming to a last question I am giving you. Write down quick. Second problem. A resistance R and a 4 microfarad capacitor. और मुझे आज बहुत प्रॉब्लम दे रहा है. Are connected in series across a 200 volt DC supply. You have across the capacitor a neon lamp देखे हो तो?
हाँ मैम. Yes
Yes,
ma'am.
ma'am.
Yes, ma'am.
Very good. Strikes at 120 volt. In neon lamp strikes at 120 volt. You have to calculate the value of R to make the lamp strike, to make the lamp strike after 5 seconds. वेरी इजी क्वेश्चन है. तुम लोग बोलोगे कि यार मैडम सब इजी बोल रहे हैं, ये सचमुच इजी है, इंटरेस्टिंग. बोलो करो करो. और 4 मिनट है, 5 minutes is there. My handwriting, all of you is you can understand, or any doubt, tell me, whichever you.
No, ma'am, it's fine, ma'am.
ये माइक्रोफैरड है, ये तुम्हारा माइक्रोफैरड है. माइक्रो मीन्स हाउ मच? 10 to the power of minus what?
6.
-6. Okay. You have connected a neon lamp across the capacitor. It strikes at 120 volt. That means when VC will be equal to 120 volt, at that time the neon lamp will strike. You have to find out the value of R to make the lamp strike after 5 seconds. Read the question twice. I will do it, but you read the question and tell me what will be the equation.
Resistance R and a microfarad is written.
R and a, sorry, it is 4 microfarad and a 4 microfarad. Good.
Oh, okay.
Nobody have written or what? Question.
मैम लिखे हैं, समझ में नहीं आ रहा, वो पढ़ रहे हैं.
अच्छा. A resistance R and a 4 microfarad capacitor. Circuit बनाओ पहले. Is connected in series across 200 volt DC supply. Across the capacitor is connected a neon lamp that strikes at 120 volt. Calculate the value of R to make the lamp strike after 5 seconds. I will do it. Tell me. क्या है इक्वेशन? मुझे बोलो पहले. That means when VC is equal to V, look at here, simple equation. All of you listen. When VC,
मैम 1.36 मेगा.
1.36 mega. Who is answering?
1.366 मैम. Wait, 36.
Who tell me your name?
Marian.
Aryan. Very good. So VC equal to V. That will be equal to how much? 120 volt. At that time, it will strike. That means what is my equation? My equation is VC is equal to how much? V whole into 1 minus e to the power minus t by RC. This is my equation. Yes or no?
Yes, ma'am.
Okay. So now here I will just substitute how much? 120 will be equal to how much? What is my
200.
supply voltage? 200. But at
Into
120 voltage. 1 minus e to the power,
E to the power minus 5
minus 5 by lambda.
5 by R into
R.
4.
R into how much? Lambda. You take it as lambda.
मैम
Okay.
yes ma'am.
You take it as lambda. So find out what is the value of lambda. Find out what is the value
Ma'am,
of
it's
lambda.
5.46.
5.46.
Oh, very nice. Very smart. 46 seconds. Very nice. Good. So now here this is equal to RC is equal to 5.46 second. So now you find out the value of R. Simple. 5.46 divided by capacitor value is given 4 microfarad. 4 into 10 to the power of minus 6. देखो इजी है या नहीं? मैं स्टार्टिंग से बोल रही थी ना, तुम लोग बोलोगे कि क्या मैडम दे दिए, पूरा एकदम इजी.
R equal to 1.366.
It's a mega ohm.
Mega ohm.
Mega ohm ना?
Yes ma'am, mega ohm.
Okay. So these
Ma'am,
type of
it's
just you
366. Okay.
366.
Yes ma'am, I think.
Okay. 366 इसमें कुछ प्रॉब्लम नहीं.
Okay.
इतना तुम लिख दोगे, R is equal to इतना ही लिख दो. यहाँ पर तुमको 99.9% मार्क मिलेगा. ठीक है?
Yes ma'am.
Got it all of you? Any doubt?
Yes, ma'am.
Next class I will teach you the decaying and rising and decaying of current in an inductor. Capacitor is finished, charging and discharging of capacitor, then rising and decaying of current in an inductor. Here, after completing the DC transient, you are able to answer to yourself why we have not used capacitor while solving DC circuit. Okay, so capacitor will not work if you are giving a DC circuit. That means it will behave as an open circuit. You give a DC voltage, you see immediately it is charging. Okay, suddenly it is charging to the full value and it is making the circuit open. So they will not work, capacitor. Similarly, after you will read inductor, you will able to know why inductors also we are not using in DC circuit. Clear? So now, so
Ma'am.
you leave, you are having class. हाँ
यस मैम, थोड़ा वो टाइम कांस्टेंट का लास्ट स्टेटमेंट कल दिखा देंगे, एक मिस कर गया था.
टाइम कांस्टेंट का लिख
No, we can go next classes.
तुम लोग जाओ, मैं तो बोल दी हूँ, जाओ.
Okay.
और
Thank you.
class-
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
हाँ, thank you, thank you.
Thank you, ma'am.
I'm done,
Thank
ma'am.
you,
Done.
Thank you, ma'am.
हो गया मैम, हो
Thank you,
गया. लिख लिया
और
मैम.
ठीक है, चलो.